Okay, welcome to the wide, woolly world of alcohols. Alcohols are fairly straightforward in terms of what they look like. Are OH. OH is just what makes it in alcohol. R, of course, is the stand-in, as per usual. As with amines, you can have primary, secondary, or tertiary alcohols. And that just tells you how many carbons are bound to the carbon that the alcohol is bonded to. So it's quite different from the amines, okay, which primary, secondary, and tertiary amines. That was telling you how many things were bonded to the nitrogen. Primary, secondary, and tertiary is telling you how many carbons are bound to the carbon. Okay. So if you have H, O, H, R. Okay. There's your primary alcohol. Then R, C, R prime, H, O, H. There's your secondary alcohol. And your tertiary alcohol is R, R prime, R double prime, C, O, H. Okay. So what that means is that for a primary alcohol, it comes at the end of a chain. Okay. Okay, so this is the carbon with the alcohol on it, and you can see it only has the one other carbon bound to it. Okay. Whereas a secondary alcohol, the alcohol comes in the middle of a chain. So you can see here's the alcohol's carbon, and it has 1, 2 carbons bound to it. And for a tertiary alcohol, it comes at the middle of a branch. Okay, so here is the alcohol's carbon, and it has 1, 2, 3 carbons bound to it. So it's quite a bit different. Another thing that distinguishes the alcohols is that they can and they can't have multiple things bound to them. It is fully possible to have something like this, but that's not an alcohol anymore. We call this an ether, and we'll be discussing that next week. Okay. Alcohols always have the OH group. So, alcohols, it either adds an OL to the name if it's the suffix group. If it is a side chain, if it's a prefix group, then it is hydroxy. Okay. So you remember that the amines were either amines or amino. For the alcohols, for the OH group, it's either an ol or a hydroxy. Okay. So here we have a nice, simple, the simplest, in fact, alcohol. Just the one carbon, the only functional group attached to it is the alcohol. That would make this meth and all. Okay, no double bonds or anything like that, so just methanol. Methanol is also known as wood alcohol because you can get it by gently heating wood, untreated wood. Don't try this with, lumber. And you'll get methanol coming out of it. Methanol is highly, highly, highly toxic. Do not drink it. It will kill you. Okay, the next one is CCOH. And this has 2 carbons, so F. No double bonds, nothing else on it, so it is an, and then all. This is ethanol, or grain alcohol. This is the fun alcohol. It's the one you drink at parties. Although you should also be careful with it because it's slightly less toxic than methanol. You have to drink a little bit more than you do of methanol to die from ethanol poisoning. But not a heck of a lot. Not a heck of a lot less toxic. Okay. So as you can see, fairly simple, fairly straightforward. And because we're limiting ourselves to alcohols and not to ethers, there's a limit to how complex I can make these, right? Well, not so much. So let's see if I can't throw some complexity at here. All right. Oh, let's go ahead and put, yeah, there we go. Okay, so in terms of priority, okay, remember we have two suffix groups on here. We have our alcohol and we have our amine. So you have to determine which suffix group has priority. And amines are at the bottom of that list. Alcohols are just above them. Okay, so alcohols steal priority away from amines. That means this guy is going to be a suffix group. Oops, sorry, prefix group. And this is going to be a suffix group. Now, we have another choice to make because we have an alcohol on the ring and another one on the chain. So, which are we going to give priority to, the ring or the chain? Well, all else being equal, you give priority to the ring. And when you have suffix groups involved, it's a matter of go with the suffix group. Well, you have a suffix group on both of those, so it's just a matter ring or chain. So now our ring has 1, 2, 3 things on it, whereas our chain only has 1 and 2 things on it. So the ring has more substituents, so go with the ring. So this is going to be an OL, it's our suffix. And that means it also gets the number 1. Then this is an amino group. And this up here has 1, 2, 3, 4, 5, 6 carbons on it. And I'm numbering it left to right because the point of attachment is where it gets the preference for numbering a side chain. So that makes this a 4-hydroxy hex and 3-il side chain. So our amino group comes first in the numbering, well, second in the numbering because it's first alphabetical for our prefix groups. So 2, 3, 4, 5, 6. So now we can name our chain. 2-amino 6 dash parentheses 4-hydroxy hexan 3-il parentheses cyclohexanol. And we don't need to number where the alcohol is because it's the suffix group. And on a ring, that makes things nice and simple. Because the suffix group, if there's only one of them, it's always going to be number 1 on the ring, and therefore you don't need to number it. And what happens if we have multiple whatchamithings on a ring or on a chain, multiple alcohol groups? Well, then that's actually fairly straightforward. It gets a prefix just like any other side chain would. So here we have 1, 2, 3 carbons, and we have 3 alcohols on that carbon, or 3 hydroxy groups. So it becomes propan 1, 2, 3 triol. So you can have a diol, a triol, or a tetrol, or anything like that. Really straightforward. Another name for this group, or another name for this chain, sorry, a common name, glycerol. Okay, because it's just a very common compound. Shows up a lot in biochemistry, unless I'm greatly mistaken, which can happen. All right, mistaken about what? About any of it. Okay. Now, another common name that you're going to see a lot is this guy. Yep, it's our old friend benzene. Pretty much everything you see with benzene is going to have a common name, and the alcohol is no exception. This is phenol. Okay. That goes with, or can be easily confused with, I should say, when you treat benzene as a side chain. because then it's a phenyl group. Okay. So if you had something like this, okay, a chain with a benzene ring on it, this would be, let's see, 3-phenyl butan 2-ol. Whereas this over here, phenol, with the OL, is referring to a benzene ring with an alcohol on it. Yeah. English doesn't do too well with distinguishing vowels in the way that some other languages do. I think that's the cause for this sort of foolishness. Not much we can do about it. These common names are going to stick around for good. And as for anything else, it's still sticking with the rules we already know. Because it's just a matter of, putting things in alphabetical order and remembering your rules for easy and etc. So this here is going to be a, let's see, 2-fluoro hept 3-ene-3-ol. Just FYI. Oh, that's a 3, not a B. Sorry about that. Let me clear that up. 15. I'm not doing much better there. Heptene 3-ol. For those of you who are thinking about going on in chemistry, an enol is a classic compound that shows up sometimes, both in organic chemistry and in biochemistry. When you have a hydroxy group directly attached to a double bond like that. Oh, I almost forgot. Same side, so that's going to be 3Z. Sorry about that. All right. Enols show up a bit in organic chemistry and in biochemistry because they can undergo what's known as a tautomerization, in which basically the molecule automatically rearranges itself. This hydrogen can hop over to this carbon, and the double bond can migrate over here, leaving you with this. Not a lowercase f, but an uppercase f. Enols can undergo tautomerization into ketones. Sometimes it requires quite a bit of work to make that happen. Sometimes it's a little bit easier than other times. It depends on the enol and the situation it finds itself in. But they do come up in those two different kinds of chemistry, as I was saying. I believe they are important. Well, I shouldn't speculate. I don't remember enough biochem to really talk too much about that. So, just be aware that you can see things like that. When you get combinations of various kinds of functionality, then they can become a class of compounds in their own right that are considered worthy of discussion. All right. Now, because we aren't covering branching off of the oxygen until next week, that means we are done for this video. And that is our coverage of the alcohol suffix group or the hydroxy side chain. See you next time.